All right, this is a question about using an equilibrium constant. So we're given a K right there for a reaction, and we're told the initial concentrations of our reactants. So we know that this is how much we have. And our question is, how much C will we make at equilibrium? And so I wanted to just pull back really quickly to say, like, this is really useful information. This is why knowing equilibrium constants is so helpful, because you can say, hey, I'm starting with this much. If I let the reaction run to completion, like let it get to equilibrium, how much of the product will I have? Okay, so that's useful. I just want to point out to you that that is practically useful information for chemists. Okay, how do we figure it out though? I noticed right off the bat that I've been given initial concentrations and I'm asked for an equilibrium, right? So these are initial concentrations and I want an equilibrium concentration. As soon as I see those two, I'm like, this is an ice table question. I should set it up as an ice table. So I'm going to have AQ plus BAQ is in equilibrium with 2C, which is aqueous, and D, which is solid. So notice that that's solid, which is important because when we go to write our K expression, like what does this 1.42, this 1.4 times 10 to the 2 equal? D doesn't have a seat at the table. That's equal to C squared divided by A times B. It doesn't mean that D is not being made. It just means that it's not going to be incorporated in our K expression. All right. So what do we know? Let's write down what we know. This is 2.5 and this is 2.5. These are both 0 to start with. Again, like this is like an NA. I know I'm going to make some of it, and so we can acknowledge that in our ice table, but again, it's not a concentration, so I don't include it into my K expression. So there's going to be some change, right? I see that K is a large number, so I'm going to favor C and D at the end of the day, but I'm starting with only A and B. So I've got to make some. So I need to be losing some B and A, and I'm going to be making 2C every time I do that because of this coefficient here, right? So you know, every time A and B combines, we make 2C's, okay? We are also making some D, but again, I am not going to incorporate that, so I'm usually not going to track it, okay? So I'm going to have 2.5 minus x, 2.5 minus x, and 2x. Okay. So notice we've got expressions for our equilibrium values, and they all depend on x. Once I plug this in here, I know what it's equal to. So I've got an equation and I've got one variable. One equation, one variable, we can solve that. So let's plug these things in. So I'm going to have 2x squared and 2.5 minus x squared because these two are the same. And this is the place where you can avoid crappy hard math. Instead of expanding this out and putting yourself into a position where you need to use the quadratic formula, which we will not ask you to do on the exam, notice that this is a perfect square. I can take the square root of both sides here. Okay, so I'm going to square root that, and I'm going to square root the K value. All right, so what that does for me is it drops out the squares on both the top and bottom. So the square root of 1.4 times 10 to the 2 equals 2x over 2.5 minus x. And now I don't have any square terms, which means I can solve this without a quadratic, which I am deeply thankful for. Okay, so look for this perfect square. It's one of the more common ways that we set up questions to allow you to avoid using a quadratic. All right, so I'm going to take the square root of that 140. And that's 11.83. Give myself some more as I go through this, equals 2x over 2.5 minus x. Okay, so I need to gather these x terms. So I'm going to multiply both sides by this 2.5 minus x. Okay, so that's going to give me, just keep going down, 11.832 times 2.5 minus x equals 2x. I distribute this, right? Times 2.5. So I've got 29.58 minus 11.83x equals 2x. Okay, now I'm going to combine terms. So add the 11.83x. As already mentioned, I have like very little love and tolerance for sig figs when I'm doing stuff like this. 13.83x. Okay, now I'm really close. I just need to divide both sides by 13.83. Okay, so x equals 29.58 divided by 13.83. 2.14. Okay. All right, and then we say, does that make sense? Okay, so we go back up here, and before you're like, oh, I got to x. Okay, I'm just gonna like plug it in, 2.1, that's what I'm gonna put in. Stop yourself. Read the question again. What will the equilibrium concentration of C be? C is not x at equilibrium. C is 2x. So I should have 2 times that x value we just solved for. Okay, so it's 4.3. All right, that's the number I'm looking for, especially in numerical questions where I do not get feedback from my multiple choice answers. I'm going to do a calculation to see if this is right, because there's so many places that this could go wrong. First off the bat, I noticed that if I put in 2.14 here for the concentrations of A, I'm not going to get a negative number. So that's good. You can't have a negative value, negative concentration. All right. So that's good feedback. But what I want to do is I'm going to recalculate K using my new concentrations. Okay. So this is my check. Okay. So answer check. Check on x equals 2.14. All right. So if that's true, I should be able to plug x into this equation. So I'm going to have 2x squared divided by x. Sorry, 2.5 minus x squared. Okay. So let's do that really quickly. I'm going to have 2 times 2.14 squared divided by 2.5 minus 2.14 squared. Okay, that equals 141, or 1.4 times 10 to the 2. I can reproduce my K value. I'm really confident now that I did come to the right answer. So my final answer that I'll plug in here is 4.3.